Hello everybody. We are back for our last chapter for the semester, so I hope everyone's doing okay. Hope you're staying well. So chapter 5, we're going to be dealing a lot with exponents, okay? So we're going to be building on a little bit of what we've done before. So 5.1 is called multiplication with exponents in scientific notation, okay? The very first part will be a little bit of a review, all right? So let's say we were given problem that says 5 squared, right? We've dealt with this before, nothing too difficult. So if you recall, the 5 in the problem was known as the base, right? That's the number you're multiplying over and over again. And the 2, if you recall, was known as the exponent, and that's telling you how many times to multiply the base by itself. So we would write this problem out as 5 times 5 to give us an answer of 25, right? So that's nothing new there. Okay, so the first section, they're going to ask you to evaluate, okay, just to evaluate. All that means is solve, we just want the answer, okay? So let's say they gave us 5 cubed, right? We've done this before, not a big deal. We would punch in our calculator, 5 times 5 times 5 to get an answer of 125, okay? So like I said, that's something that we have done before. Let's see if you remember doing a problem like this. So we have dealt with these with negative numbers. So we have negative 2 to the 4th power. So if you pay attention here, that negative is not included in a set of parentheses. Remember, when it was in a set of parentheses, you also included the negative when you were multiplying the base, okay? This is not included. This is out in front, so we will handle the negative once we get our answer, okay? So you would go ahead and do 2 times 2 times 2 times 2 to get 16. Now, since we had this negative, right, we had this negative out in front, not in a set of parentheses, that means our answer is going to stay negative. So that's going to stay a negative 16, okay? And like I said, we did this before, very beginning of the semester. All right, we're still evaluating. And let's say we did negative 3 to the 4th power. So if you pay attention this time, you'll notice that that negative is in the set of parentheses now, which means the negative is included with the multiplication of the base. Okay, so you are going to do negative 3 times negative 3 times negative 3 times negative 3. Okay, so you could go ahead and punch in your calculator 3 times 3 times 3 times 3 to go ahead and get 81. And then go back and deal with the negatives. Well, negative times a negative is positive. Positive times a negative is negative. Negative times a negative is positive. So this is going to be a positive 81. Also, you may remember from when we did this before, this only works when the negative is in the set of parentheses. So if it's in the set of parentheses and your exponent is an even number, so 2, 4, 6, 8, even number, your answer will be positive, okay? If the negative is in the parentheses and your exponent is an odd number, okay? So an odd number like 3, 5, 7, then your answer will be negative. This only works when there's a negative inside that set of parentheses, okay? All right, we also did some of these problems before with fractions, okay? So you're gonna write out the fraction just like you would if it was a whole number, and this negative's inside the parentheses, which means the negative is included with the multiplying of the base. So here I have negative 2/3 times negative 2/3. I would do what we would normally do for multiplying fractions, look diagonally, nothing cancels, so we would multiply straight across. So negative 2 times negative 2 is a positive 4. 3 times 3 is 9. Always double check to see if you can reduce, right? Nothing goes into 4 and 9. So you're done, and that is your answer there, okay? All right, so now we gotta get into some of our new stuff, right? So this was just a refresher. So that part should be nice and easy for you. Okay, now we're getting into some properties for exponents. So this is known as the product property of exponents, okay? Product property of exponents. You're going to be given several properties you're going to need to know for your homework in your test, all right? So this is the product property. So in general, this looks like a to the r power times a to the s power equals a to the r plus s, okay? So all this means is that when you have the same base and you are multiplying, you keep the base and you add the exponents, okay? So you're going to multiply same base, and then you are going to add the exponents, okay? So first thing you're going to look for, is it multiplication? Yes. Do they have the same base? Yes. So then you keep that base, keep the base, add the exponents together, okay? So let's look at an example of, let's do 5 to the 4th times 5 to the 5th power. So we're going to do our checklist. Is it multiplication? Yes. Do they have the same bases? Yes. Both are 5s. So you keep the base. Keep 5, okay? Now you're going to add the exponents. Well, the exponents are 4 and 5. So 4 plus 5. So your answer is 5 to the 9th power. And this is your final answer. Keep it there. We're going to be dealing with larger exponents, so we're not actually going to be finding out every single time what that specific answer is, okay? So this is a perfect answer, 5 to the 9th. All right, let's do a couple more of the product property. So you definitely want to make sure you have these written down or look at the PDF of the notes online, right? It's all the problems I'm doing here on the board to refresh and make sure that you know these properties because there's several of them. So let's look at x cubed times x to the 7th. So let's go through our checklist. Is it multiplication? Yes. Do they have the same base? Yes, they're both x's. So keep the base. And then you're going to look at the exponents, 3 and 7. So you're doing 3 plus 7. So your answer is x to the 10th power. Okay? And that's your final answer. That's it. That's all you have to do. Let's look at 4 to the 5th power times 4 squared times 4 to the 6th power. So first thing you're going to check, is it all multiplication? Yes. Do they all have the same bases? Yes. Each one of those is 4. So keep the base of 4. Now we're going to add the exponents. I have 5. It's a bad 5. 5 plus 2 plus 6. So that gives us 4 to the 13th power. Okay, and that's your final answer. Leave it as that. Okay, leave it as that. All right, so that is the product property. All right, we're going to move on to another one. So we did the product property. Now we are going to do the power property. Okay, power property. In general, this is what it looks like. In parentheses, we have a to the r raised to the s power, okay? So the a to the r is in parentheses, the s is on the outside as an additional exponent. So what you'll do here is you'll keep the base, okay? The base is a, you keep the base, and you multiply together the two exponents, okay? So this is a power raised to a power, okay? A power raised to a power. Keep the base, multiply the exponents, okay? So I'll write that down. Power raised to a power, okay? Power raised to a power, you multiply the exponents, okay? So let's go ahead and see an example. Let's look at 3 to the 4th raised to the 5th. 3 to the 4th raised to the 5th. So is this a power raised to a power? Yes, there's a power inside the parentheses and a power outside of the parentheses. So power raised to a power. You're going to keep the base is 3, keep that base, and then you're going to deal with multiplication. I have a power of 4 times a power of 5, okay? And then you're going to multiply. 3 to the 20th. That's it. That's your final answer, okay? So that's nothing too crazy. Let's do one more. Let's look at x to the 7th squared, okay? X to the 7th squared. Keep your base of x, and then you're going to multiply the powers. 7 times 2 to get x to the 14th power, okay? So that is the power property of exponents, okay? Power raised to a power. It's not too difficult. All right. Okay, let's go ahead and look at another one. So this is the distributive property of exponents, okay? Distributive property of exponents. So in general, this is going to look like, in parentheses, a times b, and that's raised to the r power. So we're going to have to distribute this power, okay? So we're going to multiply everything in the set of parentheses, well, not multiply, but raise it to the r power, okay? So you're going to do a raised to the r, b raised to the r. So that's what it means with distributive property, right? You're just distributing that r, that exponent, to whatever's inside that set of parentheses, okay? So let's do a couple of these. Let's see, I thought I might have one smaller. Let's look at this one. -2 x cubed y squared, and that entire set of parentheses is being squared, okay? To simplify this problem, we are going to have to distribute the square, okay? So to do this, you're going to take it one step at a time. You're going to put in parentheses that -2, and we are going to square it. You're going to take that x cubed, and you're going to square it. You are going to take that y squared and square it. It's important to have all of this in sets of parentheses, especially when we have a negative involved, right? It tells us what to do, that we need to also multiply that negative. And then it lets you know here, right, this is a power raised to a power, so we're going to apply other rules that we've already learned. Okay, so we need to simplify. So we need to do -2 squared. So remember, that's -2 times -2, right? We've done that before, +4. Okay, now here we're doing a power raised to a power. So if you recall, you keep the base and you're multiplying. 3 times 2, well, 3 times 2 gives us 6. Okay, it's the property that we literally just did. All right, now we're looking at y squared squared. So you are keeping the base of y. It's a power raised to a power. That means we're multiplying. So 2 times 2 gives us 4. So that is how you're going to be using the distributive property. So as we continue in this chapter, it's important that you study these, know the difference, have clear notes with the difference of these properties, because they're all going to be intertwined at some point or another, where you're going to have to implement multiple properties at once, okay? All right, let's do a couple more examples of this distributive property. Let's look at x to the 5th squared times x to the 4th squared. No, we're not doing it squared. We're going to do it cubed. Cubed, okay? And they're telling us to simplify, all right? We're going to start applying our rules. Well, I can see automatically that's a power raised to a power, and this is a power raised to a power. So that's where we're going to start. We're keeping the base of x, and now I'm multiplying. 5 times 2 gives us 10, okay? Now I have x to the 4th cubed, also power to a power. So we are keeping the x, the base, and multiplying. 4 times 3 gives us 12. Now we also know that this is multiplication going on here, because these were right up next to each other, right? Just like there were 2 sets of parentheses. So this is multiplication. So now we have to implement our multiplication property. Remember, the multiplication property, you kept the base. The bases were the same. You kept the base, and you added the exponents. So then you're going to be adding 10 plus 12 to get x to the 22nd power as your final answer. Okay? All right, so that was another example. Let's do a couple more, and then we're going to talk about scientific notation. Okay, let's look at 3y squared times 2y cubed. So 3y squared times 2y cubed. And the 3y is in parentheses, and the 2y, I put the cubed in the wrong spot. There we go. And the 2y, no I didn't, I wanted it in there. Sorry guys. Okay, couldn't read my handwriting. So the 2y cubed is also in the set of parentheses. Okay, so we're going to be doing multiple things here. So the first thing we need to do is we need to deal with this distributive property with this 2, this exponent on the outside. So we are going to do 3 squared and the y squared, and we're leaving the 2y cubed alone for now. Okay, we're leaving it alone for now. All right, so then we're going to go ahead and simplify. Well, what is 3 squared? 3 times 3 gives us 9. Now, this 1, right, doesn't have an exponent attached to it inside the parentheses, so we're going to assume that's a 1, right? If it's not a 1, it has to be another number. It can't be 0. So now I'm doing 1 times 2, which is 2. So now that becomes 9y squared, and we still have it times our 2y cubed, okay? Now we're going to have to apply some other rules. So this is multiplication going on, okay? Multiplication of whole numbers doesn't change, okay? You're always going to multiply whole numbers the same way. So you're going to go ahead and multiply the 9 times 2, all right? You're going to go ahead and multiply the 9 times 2. That does not change. We also now have y squared times the y cubed, okay? So we can apply that multiplication rule, that product rule of adding the exponents. So we're going to finish simplifying. 9 times 2 gives us 18. Y squared times y cubed, multiplication. Keep the base, add the exponents. 2 plus 3 gives us 5. So that whole problem ends up being 18y to the 5th, okay? Let's go ahead and we'll do one more that's a little more lengthy. You'll have examples of these for your homework problems that you can work on. Remember to check your answers in the back of the book. You can always message me if you have questions. Also, you can watch these videos repeatedly, and you have the PDFs of the notes, okay? So you do have some resources at your disposal, and I've been trying to be as fast as I can with replying to people with problems, so make sure you send me a message if you need to. All right, let's do another one. So let's look at 3x cubed, y squared, and this whole thing is being squared. And let's look at 2xy to the 4th cubed. So it's a large one. We're going to take it one step at a time. Okay? The 2 and the 3 are letting us know that we need to use that distributive property. Okay? The exponents here lets us know we need to distribute. So we're going to go ahead and separate this. This is now 3 squared times x cubed squared times y squared squared, right? That was just the first section. We need to do the same thing here, but with a 3. So this is now 2 cubed times x cubed times y to the 4th cubed, okay? And from here, we're going to start simplifying. So we can do 3 squared, right? We've been doing that. So 3 times 3 gives us 9. Now here I have x cubed squared. That's a power raised to a power. So this is multiplication. So this becomes x to the 6th. 3 times 2 is 6. Here I have y squared squared. Power raised to a power. We kept our y, we kept our base. 2 times 2 gives us 4. Okay? Gives us 4. All right. Now, I also have over here that we're multiplying by, right? We have our 2 cubed, our x raised to the 3rd power, y 4th raised to the 3rd power. So 2 cubes easy, right? 2 times 2 is 4. 4 times 2, gives us 8. We know how to do that. Now I have x in the third. So remember, if there's no number there, it has to be a 1. So it's a power raised to a power, so we're multiplying. So that becomes x cubed, right? 1 times 3 is 3. Here with our y, I still have a power raised to a power. We're multiplying. 4 times 3 gives us 12, okay? From here, we have a little bit more work to do. This is multiplying. So remember, multiplying numbers doesn't change, okay? So you're doing 9 times 8. Well, that gives us 72, okay? We know how to do that. Now I have x to the 6 times x cubed, okay? And I also have y to the 4th times y to the 12th. So I need to apply our other rules, right? When you're multiplying and you have the same base, add the exponents. So this is now 72. Multiplication, keep the x, and add. 6 plus 3 gives us 9. Here, I still have multiplication. I'm keeping the y, add the exponents, 4 plus 12 to get 16. So that entire problem was 72, x to the 9th, y to the 16th. It's a little bit of work, but if you take your time, take it one step at a time and apply the rules, you'll be okay. All right? You'll be okay. All right, the last thing in this section is dealing with scientific notation. So we've done this before, okay? So we're just going to go ahead and go over this again briefly. All right, scientific notation. We've done this before, okay? So this is in the form of n times 10 to the r power, right? We know that's scientific notation. So let's say they gave us the number, let's do 4,810,000, right? And they want it written in scientific notation. Remember, you are writing this as a decimal, okay? You're changing this to a decimal, and you only want one number to the left of the decimal, okay? So to make that happen, this is going to become 4.81. I don't need those zeros. It's a decimal. They fall off, okay? I don't need those zeros. This becomes 4.81. I want one number to the left of the decimal. That's the 4. Everything else follows, okay? Now, we know this is going to be times 10 to some power, right? We got to figure out what that is. So you need to know how many times you need to move this decimal to get the original number, okay? So if I have my decimal here, how many times does it take to get back to the original? 1, 2, 3, 4, 5, 6. So that answer is 4.81 times 10 to the 6th power. And like I said, we've done this before. Okay, let's look at another one. Let's look at 5,473,000. Same thing, we want to write it as a decimal with one number to the left of the decimal, so it's going to end up here as 5.473. I don't need the zeros, they fall off, but I need the other numbers, okay? Times 10 to some power, so we're going to count how many times it takes to get us back to the original. So if I put the decimal here, it's going to be 1, 2, 3, 4, 5, 6. All right, so that's 5.473 times 10 to the 6. And we have also done this with given decimals. So let's say they gave us 0.0038. And they said to write that in scientific notation. You're still doing the same thing. You still want to write this as a decimal with one whole number to the left of the decimal. So that's going to end up being right here. So this now becomes 3.8 times 10 to the, we're not sure, okay? Now, when dealing with a decimal, this is going to be negative because you're moving in the left direction to get back to the original. In these problems, we were moving in the right direction. It's going to be a positive exponent. When we're dealing with an original number being a decimal already, this is going to become a negative exponent, okay? So we know we put the decimal here. Let's see how many places it takes to get back to the original number. So we had to go 1, 2, 3 places to get to the original. So that becomes a negative 3, okay? So 3.8 times 10 to the negative third. Let's do one more. Let's look at 0.00042. So it's the same thing we did before. I want to write this as a decimal, but I need one whole number to the left of the decimal. So this becomes 4.2 times 10 to the, now the original number is a decimal, which means this exponent is going to be negative. Start here where we placed our decimal. See how many places it took us to get back to the original. So we're going to the left. 1, 2, 3, 4. So our answer is 4.2 times 10 to the negative 4th power. Okay? Hopefully you remember doing this at some point. If you're in my Dem 100 class, if you're in my Math 95, right, we have done this previously. All right, so there's one more quick last thing that we have to do for this section. And it will be quick. All right, they want you to write in standard form. Write in standard form. All this means is they want the full number written out. Okay, they want the original number. So if you want to remember, this is the actual number, right? That may help. Okay, so let's look at 3.05 times 10 to the 5th power. They want it written in standard form, so they want the actual number. So what you're going to do is you're going to take this 3.05 and you're going to move the decimal to the right 5 times. Now how I know it's the right is from the exponent, okay? The exponent's telling you where to move. It's a positive 5, so that means you're moving it to the right 5 times. So I got my decimal and I'm going to move to the right. 1, 2, 3, 4, 5. Okay? Now I have these blank spots here. I need to add in zeros. So 1, 2, 3. So 305,000 is our answer for that problem. So you need to pay attention to the exponent. If it's positive, you're moving it to the right. Okay, you're moving it to the right. All right, let's look at one with a negative. Let's do 3.05 times 10 to the negative 5th this time. Okay, so once again, you're going to start out with your decimal. They gave you the 3.05. Now this time, the exponent says a negative 5. Okay, so we know we're moving our decimal 5 times. The negative is telling us that we're moving it to the left, okay? To the left 5 times. So I have 1, 2, 3, 4, 5. Now you notice these blank spaces again. I'm going to add in zeros and a decimal for this problem. So our answer is 0.0000305. Okay? All right, so that's the end of 5.1. If you have any questions, please let me know. All right, see ya.